this is K for Unit 1, the AP workbook, and it's a continuation of J. Right, we've got this rocket. Initially, it's at rest on the ground. It gets launched, right, and it's increasing speed while the engines are burning. Once the engines stop burning, it's going to continue moving up, but it's going to slow down under the influence of gravity until it gets to its highest point where velocity is 0. And this is at max height. And then it'll turn around and fall. Okay, we already drew a velocity versus acceleration time, velocity time graph for the first 10 seconds, and that's not going to change. It's accelerating at 5 meters per second. Let me number these. I think I did that wrong. Sorry, my printout didn't come out good. This is 2, 4, 6, 8, 10, and this will be -2, -4, -6, -8, -10. So for the first 10 seconds, it's going at +5 meters per second squared. And then as soon as it's finished burning, then it's going to drop pretty much straight down to here. So you're going to have this vertical drop. I drew in a dotted line. You don't even have to. You can have 2 line segments, right? This is the engine, right, burning fuel. This is coasting up until stopping at max height. Okay, well, we don't know how long that is, but let's just assume, okay, for now. So let's draw a graph of velocity versus time. And similar to before, we're going to use the area under the curve to figure this out. So we figured out last time that we got to a maximum speed of 50. So it went 10, 20, 30, 40, 50 in those first 10 seconds. So we got up to here. And then it's going to decrease, right? We're going to need to do our change in velocity by figuring out the area here, but we also know the slope, right? The slope is the acceleration. And acceleration due to free fall is -9.8 meters per second squared. Well, this might be a little easier to figure out. I'm just going to use -10. All right, let's just round it to make this simpler. So each second, I'm losing 10 meters per second. So in 1 second, I'm down to 40. In 2 seconds, I'm down to 30. In 3 seconds, I'm down to 20. In 4 seconds, I am down to 10. In 5 seconds, I'm down to 0. So I can see that in 15 seconds, I have reached 0 velocity. This is my maximum height. Let's keep going. So where will I be the next second? In the 6 seconds later, I'll have dropped another -10. So from 0 to -10. The next second, I'll be at -20. The next second, -30. The next second, -40, and at the end, I'll be going -50 meters per second. So this is my rising and falling, right? All these values here are positive velocity, which means we're moving up. All of these are negative velocities, which means we're moving down. And you're going to have to tell yourself that about 100 times before you get it. If you just assume that this is a position time graph, you'll really be thrown. So that's how I estimated it. You can also use the area here. So the area of the second half, right, is a rectangle. It's base times height. So from 10 to 20 seconds is 10 seconds. The height here is -10. So you have to cover -100 meters. So meters per second, sorry. So your total changes is 100 meters per second in the negative direction. So if you're at 50, that puts you at -50. So you end up with the same exact thing. This is more doing calculations. This was kind of using it more conceptually. Using the kinematics equation, y equals yo plus vyo t plus 1/2 ayt squared. Okay, recall that this o here, this is what we call naught, which means the beginning or original, however you want to think about it. You'll also see it as initial. So any of those words is fine. So same thing here. These y's here, this one and this one, means we're referring to y-axis motion. So the equations apply to, you could just substitute x's in here, right? Here's y, 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 y. You could change these all to x's. You'd be working horizontally. So using this equation, a classmate writes out the following solution to find the time when the rocket lands back on Earth. Explain in one sentence using terms, acceleration, velocity, position, constant, changing, and zero, why the solution below is incorrect. Okay. So you start at zero, you end at zero position. You start at zero position. Your initial velocity is zero. Time, this is the initial acceleration, and this is the time. Okay, so there's a couple things wrong with this. This and this is correct if you're taking it from the beginning to the end, if their time is 20 seconds. But the initial velocity is not zero, right? Oh, sorry, it is zero. My apologies, I forgot. So the initial velocity is zero if you're doing the whole thing, right? But the acceleration is not 5 for the entire time. So this is incorrect if you're using the time is 20 seconds. So the problem is that if you have two different accelerations, you can't use this entire, you can't use 20 seconds. So you need to say then that you have to figure out your initial position and your final position, right? Then this needs to be fixed. So you can only use, if you're using this acceleration, right? So let's write it using these terms. So the acceleration is not constant, therefore the equation cannot be used for 0 to 20 seconds. You would need, right? You would need more than one equation. One for the increasing speed portion, and one for the negative acceleration portion. Let's change this to positive acceleration. Okay, so hopefully that makes some sense. From your velocity versus time graph in part B, determine the time when the rocket reaches maximum height. So we've kind of already talked about that, right? This is going to be, right, where v equals 0 is your maximum height. So that looks about 15 seconds. So when the VT graph crosses the x-axis, velocity is 0, which occurs at maximum height. Make a claim about the numerical value of the rocket's maximum height. The rocket's maximum height is equal to, well, I would want to find this total area. So we can do that by splitting this into, well, two triangles. So the area, actually you don't even have to, you could use one triangle. So you would do, your maximum is 50 and your That's your height, and the total time is 15, so that's 25 times 15 equals 375. So the area of the velocity time graph is displacement. So they're asking for the physical feature, you just have to back that up.